Hey there, pre-med. In this video, we're going to cover one of the most foundational general chemistry topics, the 6 major types of chemical reactions. This video is a sneak peek of a lesson series that I'm building on MCAT Essentials and Foundations. Let's get started. We're going to use this chart to contrast the types of reactions, the reactants we start with, and the products we finish with. Go ahead and fill this chart out alongside me so you can have it in your notes. Our first type of reaction is the combination reaction. In a combination reaction, we take two individual reactants, we'll say A and B, and combine them to form a single product, AB. As an example, we can take hydrogen gas, 2 moles of it, plus oxygen gas, and form 2 molecules of H2O, or water. This is our combination reaction where we take two things and click them together. Our second type of reaction is a decomposition reaction. Decomposition reactions are really the opposite of combination reactions, where we have two things, A and B, and we split them into A and B by themselves. So we had a combination, we had a molecule or a series of atoms bound together, and we decompose or separate them. We can do the reverse of our combination reaction here, where we take our 2 water molecules and separate them back into hydrogen gas and oxygen gas. Our third general category of reactions are called displacement reactions. For the purposes of comparing and contrasting, we're going to put them into 2 categories, single displacement and double displacement. In a single displacement, we're essentially taking one atom or element out of a compound and replacing it with another. So using our annotations here, we can have A, our single element, usually a solid, plus BC, where BC are a compound bound together. And let's say that we're replacing B with A. So we end up with AC, and then B is now left over. So we did a single displacement where we displaced B and replaced it with A. As an example of this, we can take copper, solid, it's usually a solid metal, plus silver nitrate, where nitrate is one part, this would be our C, and then silver is our B, and we can replace that silver with the copper. So we'll end up with copper nitrate and silver solid. And that's a single displacement. So the key to this is usually we have an individual element or atom coming in and displacing one component of the molecule. Double displacement is we have 2 molecules and they basically trade. They trade atoms or they trade elements. Another name for double displacement reactions that you may come across is metathesis reactions. Let's draw our general example. So we'll have a compound AB plus another compound CD, and then we will essentially exchange 2 elements. So we may end up with AD and BC. So we've now essentially traded partners where B and C are now partners and A and D are now partners. Let's do a real world example with some salts, as ionic bonds often are doing these double displacement. So let's use our silver nitrate again. This is a common one we see in these reactions. So that'll be as our AB, and then we'll add that together to our classic salt NaCl. Now we're going to trade. So our Ag will interact now with our chlorine. So we'll have silver chloride. And then we now have our sodium, NaNO3, nitrate. So again, in double displacement, we have 2 molecules and they're trading partners, where single displacement, we have somebody who's single on their own displacing somebody else. Our final 2 reactions are a little bit more specific. These 4 are very general. They can be kind of any elements. We'll now get into more specific elements with our combustion reactions. In a combustion reaction, we have a fuel, usually some kind of carbons and hydrogens, plus an oxidant, usually oxygen itself. Oxidants, by definition, remove electrons, right, from another atom or element. So now what we have is we'll have a fuel plus an oxidant. The key identifier for a combustion reaction is its products. It always will produce carbon dioxide, CO2 gas, and water. So you'll know that this is a combustion reaction specifically if these are our products. For example, we can have methane gas, CH4, that's our hydrocarbon, plus our O2, our oxygen gas, and we'll find that we can produce CO2, and water will just have to have 2 molecules of O2 and 2 molecules of water to balance out our number of atoms. This is a classic combustion reaction. Our final type is called a neutralization reaction. Now, a neutralization reaction is a subtype of a double displacement, but I like to have it in its own category because in a lot of our biologically relevant reactions, we consider neutralization their own category. In a neutralization reaction, we have an acid that reacts with a base. So an acid is something that's donating a proton or accepting electrons, and a base is something that's accepting a proton or donating electrons. And we have the acid plus the base getting added together, and when we have an acid and we have a base and we mix them, they neutralize. Neutralizing produces a salt, which again is just an ionic bond like NaCl, and water. So again, you can see how combustion and neutralization are subtypes. They're kind of specific, but they come up often enough on questions and in biologically relevant reactions that it's good to have them in our chart. As an example here, we can use our strong acid HCl, hydrochloric acid, and our strong base, sodium hydroxide. And what's going to happen, again, it's double displacement. So our sodium and our chloride are going to form our salt, and our hydrogen and our hydroxide, our OH, is going to form H2O. So again, it is that subtype of AB plus CD flips it. It's just what we're flipping is we're becoming water with our OH and our H+, and salt with our metal and our non-metal. So our metal being sodium and our non-metal being chloride. Okay, we now have the 6 major categories of chemical reactions locked down and ready for test day. If you found this basics video helpful, go ahead and let me know in the comments below. And as always, happy studying.